Hey everybody, I'm going to get us started. So before I introduce Lauri, I actually have some really wonderful good news. I don't know how many of you have heard this, but this is a really important announcement. But Dr. Melanie Cooper here, Professor Melanie Cooper, has just been a member of the National Academy of Education. Very prestigious award, and that's an award, honor. And I think, my guess is Melanie is the first Deber type person that's been elected to the Academy, which is very cool. But it really is filled with a bunch of psychologists. It really is. It's like, it's truly like 95% psychologists. And then there's a couple of other people. Now they're our first Deber person there. So that's very cool. Congratulations. So now I get opportunity to introduce Lauri. Lauri is from Estonia. I've known Lauri, I think now for about 3 years.
Yeah.
I met him first, one of my colleagues from Estonia, Mia, as well as a colleague from Finland, Jari, that some of you know, as well as from Israel, Rahel, had a grant from the European Union actually to bring together graduate students from the 3 countries to help promote their professional careers and development. And that's where I met Lauri first. And he wanted to come and learn a little bit about CREATE and what we do here. So he wrote a little small grant, always important to write little grants, and to be able to come here and basically interact with some of you and learn about what we're going to do. So he's going to talk about the Estonia education system and his PhD research. I have to tell you this thing, Estonia is a really small country. There's actually 1.3 million people, so it's small. They have 2 cities, Tallinn and Tartu, which take up probably over half the population, but they're smaller, 250 to 300 people each. I was there for 6 days. Of those 6 days, I ate at 4 Michelin restaurants. Wow. Now you go figure that. I was like shocked. And not only that, the food was really, I mean, you can say, was Michelin restaurants really that good? The answer is yes. I've now eaten at 6. 4 of them have been in Estonia. It's crazy, right? Anyways, so Lauri, welcome. I hope you enjoy your visit. We look forward to your conversation, your talk.
Yeah, I'm so pleased to be here. Last year I met Celine in Esera summer school. So Narst has also some summer school, but it's quite new. But Esera has the opportunity to provide also for European PhD students the summer school for 2 students from US. So, and Celine told that, oh yeah, do you know who is my supervisor? And I said, well, I need to be there. It's like I have told, it's like for Catholics, it's like Vatican. For Jewish people, it's Jerusalem. And for science educators, it's the great institute here. So it's the Mecca where I am now. So yeah, I try to make it so that we could have a seminar to talk more. You can ask questions, and it's always good to give some sort of an intrigue here that maybe I can shock you somehow. Then you will think that who is this? And Ehud Aviran, who is also here, I don't know,
he's at a meeting. There's unfortunately there's a meeting going on that we couldn't change because it's got people from other states.
Oh,
so.
It's good because Ehud has grilled me many times in these PhD doctoral schools. We have many meetings. Ehud is always saying, "You are presenter. You need to sell your product." And usually, at first, like first year, I did like, "Hello, my name is Lauri. This is my research." And Ehud was, "Sell your science." So I try to do now a little bit promoting also and adding my non-theatrical skills, but I try to do more to do my work. So, yeah, so if you talk about Estonia, these are the first things maybe you need to know. Yes, compulsory. Mia didn't probably gave you one, but it's in dark times it's needed, and type F power sockets also important. So yeah, 1.3 million people. It's 3 times smaller than Michigan even. Quite small, and it's quite unique that actually in the history we have such a small countries. They really don't exist, so small countries. It is quite rare. And what is also interesting that it's the country of pagans. 70% of people are not related with any religion at all. 1918, when we got our independence, over 100 years ago, it was written in the constitution that every person has the right to choose their own religion, and it happened that if you have right to choose, nobody is not choosing anything. So it happens, but we have 27% of people who speak Estonian as a second language, and mainly they have Russian as their first mother tongue. Yeah. So we are not former Soviet Union country. I want to say that we have been formally occupied by Soviet Union because we were free at the beginning, and then we were occupied for, let's say, 50 years, and then we got restored our independence. Since 2002, we can give digital signatures. We have, I have this ID card. I'll show you. It's my identity card, my driver's license. Here is the chip you can insert to your computer, and you can do taxes with 2 minutes. So everything is online. Boom, boom, boom. Bank, schools, everything.
Nice.
I don't know where you have to give signatures. No, yeah, everything. Yeah, and we save lots of days for this, and we are very proud of it. We are trying to sell it globally everywhere, but it's hard. It's hard to find the believers who will think that this system is good, because you will lose lots of people in the bureaucracy. And they need to do something else. So, and maybe the culture is something that we are very proud. So if you look 1.3 million inhabitants, and almost every person statistically is visiting theater once in a year. So this is something, yes. And population, yes, like Joe said, basically two major cities. Tallinn has like 500,000. Tartu, where I'm from, Logos, always you need to promote in Europe, where are you from, has 100,000 like here. So it's also a university city, and from 1632 it was established by Swedish king, who died after this at the same year. So yeah, why we should speak about Estonia? I'm getting there. We have the typical education system. Yesterday I already shocked some of Melanie's students that we start school at the age of 7. What? 7? Well, I said, well, when it's 1.3 million people, there is no competition. We don't need to push it down. So, and we don't have to read before age of 7. We start to read here when we go to school. But most of the children, they are going also to this kindergarten, so it's called like preschool. So teacher salary, you can see it's not much, but it's something we are working right now. Of course, it always depends which are the living standards. Since you are here driving lots with car, I can say that petrol price is times 1.5. If you look your it's you multiply it by 1.5, then you know that it's not owning a car in Estonia very good thing, because it's quite expensive. Most of the cost goes to petrol. Yes.
That's a monthly salary?
Yes.
Okay.
Yes, that's monthly. Yes.
I was a little worried that it was weekly or
No.
yearly.
Yeah, no, it's monthly salary.
Still not much.
And it depends on school, but mainly you need to
$2,000
give
a
like
month.
24 lessons with full time. But in total you have like 35 working hours. So it means that you, as a teacher, have some time left to prepare your lessons, check the tests, and so on. So yes, and if you are class manager, so for example you have like 24 students in the classroom when you are in this basic education. In the secondary there is 36, but here is the 24 maximum amount. Then you can be also like managing the class. You are the so-called link between children and parents, and school. Yes, Paul.
And how much does a Big Mac cost?
Big Mac. Big Mac meal is
Or a gallon,
$8.90, let's say.
90 euros?
Yeah, 8.9 euros.
So 9 euros.
So it's definitely cheaper than here in the airport when it was like $50. Yes. Yeah, it is cheaper, but we are not anymore developed country. We are getting, the prices are getting up. But why? This system is more or less the same. At the end of the basic school you do 3 exams. Here also 3, and some of the universities are doing their own exams. But why we should talk about Estonia? Well, look at this. Boom, 2022. What is it? Something strange? No, if you look, 2015, 2018, PISA. Somehow we are called like, maybe the only religion that Estonia has is the PISA and our education. So this is our religion and we are so proud of it. And that's why for me it's the culture question, because if you look at these first 6 countries, well, they are totally in the different area and they have total different culture than Estonians. And it's you know, if you think of what is the greatest educational system, probably in the Europe everybody will say that, oh, it's Finland. Because over the years, when they started to participate in the PISA, they showed really good numbers, but there is a decline in their scores now. But they were really good at selling it. So they are still really good in selling their education system globally. Lots of visitors. But in Estonia, it's, I don't know, we are not selling it yet so good, but we should. So yeah, but you may think, okay, PISA. How many students participate per country? Well, it's 6,000. Well, if you think of Estonia, 6,000 is like over 40% of all the students. So, and schools, it's again like 40% of the schools who would participate. So it's not that, well, the statistics is maybe on our side, that something is happening there. And it's not really rare, yeah? We have, I don't know, what is there? And what is, that's my question. But it's not yet my study, but this is why we should talk of Estonia. So this is, my focus is 7th to 9th grade science education, and this is our curriculum overview. What is the structure? In Europe we have to have, when you finish your 9th grade, you need to jump over the bar with these 8 key competences. These are quite common in each European country, so these competences you need to achieve. How you achieve? Well, you need to have some literacy, and when the literacy in action, then it becomes competence. And what I mean by literacy, it's the VASC, values, attitude, skills, and knowledge. So these are written in every subject, and then we have these cross-curricular topics that we want to and we need to promote in every subject. So this is the general overview of the structure. And now when I go to my studies, what I have done in Estonia. So when I started, one of my professors said, "Hey, are you doing curriculum study?" And I said, no, I'm just, energy. I'm more, focused on energy, but he's great. He has this inquiry-based research, and he knows lots of things, quite high score. And yeah, so it happened that I started to look deeper what's behind our curriculum, what is written there. Because I wanted to build assessment to know how good the students are knowing about the topics that is related with energy, and Europe has this goal that 2050 we should be net carbon dioxide emission 0 level, so that we don't, everything we produce, we take it back. So my PhD is more related with this, that when I finish, hopefully soon, that to, let's say roughly 25 years before, are we prepared or not? So, or how well we are prepared? Do we need to do any changes? And this is typical, you may say it's syllabus, yes. In general, but it's written per one subject. So here is like 1 out of 11 topics that are in chemistry, and I started to look, well, what we need to do there. And I started to look at these verbs, because they are giving us what we cognitively should do, how highly we should aim cognitively. So if you know different taxonomies, then I will get to this, but yeah, the Bloom's taxonomy, so you have the knowing, understanding, applying, analysis, evaluate, great, so it's there. So how far you need to reach them. And these learning outcomes are usually written in under 3 different domains. So is it cognitive, affective, or psychomotor? And what happened that I analyzed the 7th, 8th, and 9th grade. We have biology, earth science, or so-called geography, physics, chemistry, and this, in the 7th grade we have this interdisciplinary science that is like pre-course for physics and chemistry. And I looked at all the learning outcomes under which domain they go, and well, in total, these verbs are giving like 782 learning outcomes. Is it like, at first it may shock you that you need to know so many things by the end of 9th grade. But when you start to look, its average learning outcome per one lesson is like 1. Well, that's not big enough. Maybe more, it's quite smaller number. But then again, when somebody goes to school field trip, boom, your lesson is gone. There is like sports day, boom, your lesson is gone. There might be some musicians come to our school to give a concert. Everybody's going, boom, your lesson is gone. So it's not 100%. It's statistical number, but it's changing mainly. So okay, definitely the problem is here, the affective. So we don't value enough, for example, in physics. Why this is problem? Because average teacher, they may not even read daily basis the national curriculum. They are using textbooks, workbooks that are built based on the curriculum. They are trusting the system, and the government gives stamps that yes, this is in coherence, these materials are used, very valid, and you can use them. So if we don't make any specific learning outcomes, on affective domain in physics. So how do people start to value this if you don't teach them? So this is the question. In chemistry, what is interesting that basically 2-to-1 ratio between cognitive and practical works, and well, it seems like okay, but like if you think statistical average, that after every 2 lessons you will do 1 practical work or lab experiment. It seems good, but not all the facilities have the lab, so it may happen that it comes like really teacher-centered and cognitively overloading from one side. You need to use different learning domains to have this very big development inside you. So this holistic approach. So yeah, so there are some limitations, but okay. Then I started to look here. I took some risk and I generalized the comparison between Bloom's taxonomy, that is Anderson and Krathwold revised, and the Solo taxonomy, that is structured observed learning outcomes. And I used some generalization that these are the Bloom 1 and 2 are the lower levels of cognitive learning outcomes, and starting from apply level, these are the higher ones. And well, then I looked at what's happening here. And well, in biology, basically, you have something interesting that you have only one, basically like one fact or thing that you need to learn before 7th, 8th, and 9th grade. But then it means that, but it's not so. It means that when you go to this, check deeply these learning outcomes, they are hidden inside. So there is like maybe more of analysis level learning outcomes, and all the lower ones you need to do it before. So they are like hidden. But mainly it's there like 45 to 55 or 50-50 distribution. And that was my presentation, and in the first year I was able to reach here, and well, then came this question. And it was nice. I was a little bit shocked, you know, 2 months I have studied something, I did my research, and then just really simple question. That if we meet one day, what you gonna tell me about your, and I was like, yes. So I was quite shocked. You know, in the beginning, when you start your PhD, you need to know the big questions. But I always looked very like specific, very small. And this, I didn't have any answer. So I needed to look deeper again, do the analysis once again. So I checked this, I compared, but it was a side study, but just to make you something that when I looked at these dark ones are the lower cognitive learning outcomes until here. Estonia is rated like here, or distributed from here, one side, and the others are. And I can see that our PISA main like our top competitors, they have really much lower level cognitive learning outcomes, and Estonia has some sort of a strange situation that is like 50-50 distribution. So, what is there? But how we can succeed this way? Well, maybe the competition, that we don't have it in our society, we don't need to compete, and we can just do whatever we want. It's basically American dream. You can be anyone since there is no competition. So there is no unique formula to succeed in PISA. It shows that we are like, and I don't know, we are something different there. And I still don't know. So, but based on Joe's comment, I started to look this energy, because this was really my thing. that it's, you know, it can be, in science education, it's stated it can be form, it can be energy transfer, transformation process, dissipation, conservation, and I started to look how are these learning outcomes related in the science education, and I found out that mainly, like there was like every third of learning outcome in the science education is related with energy. Well, yeah, it seems quite logical, and now I could have the answer for Professor Krajcik that yes, your same system that you have here in the NGSS, I have proved that it's also in Estonia happens, that it's quite universal, that it is the same thing, but mainly it's related with the energy transfer and transformation process. So this is our key. So what it gives you, that if you want to do multidisciplinary or at first maybe interdisciplinary cooperation between physicists and chemistry and biology, so maybe the key to start is looking similarities on energy. Then you can find something that you can find a way to cooperate. So that was this thing. And I was hoping that, yes, my work is done, I submitted, boom, and then rejected, 3 times. And then Mia, who is one of my supervisor's, let's say, husband, asked that, again, very strong question. What is the relevance of your work? And when you start your PhD, you never have these answers, but you need to have them in the beginning. So it's missing relevance, and I was again like, again. And then I found this Stuckey's paper that is what we should promote in the science education, that the learning should be in the individual level, in the societal level, and we should promote in the science education the science career. And I found out that, well, science career, I know why we are lacking also Estonia to have students who will go study in the STEM field, but we don't even promote it with learning outcomes. So that's a problem. And now, yes, I was accepted, first publication out. And then my supervisor, Jack Holbrook, comes with another question, like, where is your focus on your PhD? And then I'm shocked again. Narrow it down. Jack is one of the favorite comment that he is always saying, narrow it down. I didn't understand what it means. And then one professor in Chemistry Institute said, well, it doesn't matter in which discipline you are. Nano level. Go to nano level, not 2 digit after comma. Nano, go really deep. Then, okay, start again. And I started to focus on more, like, what should be the problem, and I didn't have the design yet, that what is the main framework, that how can theoretical framework. Last week I heard Barbara's presentation in Estonia, and I wish that I had the presentation that Barbara made it 3 years ago. Or 2 weeks ago. I wanted to have it like 3 years ago, because I did everything the opposite way, and I have failed so much. But I wanted to make this test to see that how students are knowing or understanding this energy concept, because the research previous has showing that there is a problem. So I started to develop this instrument, but again, another fail. You never do 2 studies at the same time. So it may happen that your first study is rejected, then you need to do again, you find something new, and it gives totally different indicators for your second work. So again, so many mistakes I have done But each time it's, I don't know, my supervisors are also saying that it's not that we have unique formula how you do your PhD. Each time it's tailored process. So, okay, but I had a vision that I want to have, if I do this energy concept test for students to see how they will understand it, that I have this three-dimensional idea. First, the components of energy and the subjects and the cognitive development in this process. It looks like really nice idea. It's three-dimensional. Well, and what happened was so that even if I wanted to have learning outcomes that are specifically related from our curriculum with some specific level in the cognitive development, I wasn't able to reach them all. But 16 items were there. Teachers were saying to me that, okay, you can come and pilot to my class, but 45 minutes is one lesson. Then I did the calculation that, okay, 3 minutes per item. Okay, this is something that maxes out my time that I can use it. So, yes, so it was, I was quite happy. It was like storytelling that father is going with the son Alexander to a field trip. They see lots of things and they meet, and then they go to sauna and they see stuff there that are related with energy, and then they go outside, and it was like beautiful story, and yeah, but never underestimate the power of statistics. So, boom, I started to, first I opened SPSS and started to look that I had some structure. I started to look confirmatory factor analysis. Nothing, none of the things that are written here. No factors at all, no latent variables, no, nothing. Everything is wrong, but it looked so beautiful. So, so yeah, even if I eliminated 3 items, but the Cronbach alpha is still so low. Oh, stress again. First 2 years of PhD, it's mostly about stress. But when you're third year, you start to smile. Like now, it's really stressful. But I saw that there are some groupings, so there should be something. So we did qualitative analysis about the items that we have, that maybe they are under some factors. And one of my professor also in the education department said, well, if you want to be successful, ask everything everywhere. And well, yeah, I asked my supervisor, you know, Rachel, yeah, okay, David, I know David works upstairs. Come to Israel, talk. David looks my data and says, noise, full of noise, eliminate the noise. Think everything that can do some sort of cause some errors. So, okay, I started to recreate, and then again, ask everything everywhere. You know. And then I present my work to Jari, and I said that, well, I have this, you know, curriculum, I have analyzed this, you know, I want to build this test, and I want to do later interviews with the teachers. And Jari says, well, it's a curriculum study. And then what? I said 2 years ago, it's not curriculum study. And then my professor asked, yes, are you doing curriculum study? And then finally, after 1.5 years, I said, yes, I'm doing curriculum study. So you never know that at the beginning, I suggest you, if your professor is saying something to you as a comment in the beginning, that maybe you should look this, then the answer is yes, please look this. Do not force or fight against it. So luckily, some sort of a miracle happened that I was, whoa, it's like Tim's test. So yeah, the math and science tests that are done with the 4th and 8th grade, lots of countries are participating in this. So I get the same framework. now I had my theoretical framework, and then now I had the structure for my PhD. You know, we need to have this design. We need to have some sort of a framework, and I was now able to see that where I'm leading, like what is my main framework, that what is my outcome. And actually now it's a little bit also changed, that here should be like energy transfer transformation process. But first paper was out, I'm more now focused on the second test, and what happened? So I needed to eliminate the noise. What I did, so David says add more items. Definitely add more items, but because after statistics, or after you have used some sort of software, it may show you that not all the items are matching. So please add more, then you can always take them down. Okay, so if I add more, then I need that this content that is written before, it needs to be smaller, then I reduce it. So it may happen that if you look, this is my first version, that the length of the answers, well, to reduce the noise, I made them all more or less equal with the characters. So I did it so. This was also one. And then I looked deeper about the TIMS cognitive framework, and there is like things that are in knowing level, applying level, and reasoning are the research skills that are universal in every discipline. I get rid of this interdisciplinary science, less is more, chemistry, physics, biology, and earth science for disciplines, and this is used like all research skills are basically that has NGSS also. So things that are universal in every subject. So, okay, and David said, find a perfect formula how to code your answers. So I found this paper, Greca and Moreira, in 2001, and that paper said that at first when you learn science you need to have physical model inside your head, and then the mathematical model can support it. So based on this I started this coding idea that if the physical model is okay, math is okay, full max score. If physical model is okay, but you don't know the math, 3. If math is okay, but you don't know the physical model, then 2. If you both are incorrect, then 1 point, and if you are not responding, then 0. Then okay, I have some structure. And I piloted again, and whoa, it looked, you know, at first so many errors, and now it already looked better, like boom, 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 boom. I saw the numbers, if you have done the IRT, that, oh, it already looks so good. It was better than Herman Abel, and even a little bit better than David Owenberg. But of course, my number was of participants were smaller, but I was so proud. And then our professor, Margus Pelaste, said, you know, 10 years ago, Rash, okay, but now we are doing M+. Latent variables, go to M+. And then I look, no, my model is not working. We need 95%. Oh, it's like you have like already, you have like gold medal, and then it's like, okay, go to do world record also. Now I need to do it again. I was so happy that the test item mean, I was able to reduce it 3 times, but it's still not here. Okay, I have seen publications, but when items are too hard, it's accepted, you know, but never with the positive side. But it looked already better. The latent variable model was almost okay, so I need to refigure it. But what happened when I looked the RAS, that it happened that I needed to change my model a little bit, because when I had the idea that physical model needs to be correct, the phenomena, and math incorrect, now I needed to change it. Because students are using some sort of a logical idea, for example, balancing reactions. They say, oh, math, boom, 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 logic, boom, boom, boom. And well, that was shocking to me also, that why, you don't know the phenomena, but you are able to see some sort of a math connection there. So it may happen that, you know, in the puberty, the mind is you know, it's strange. So I need to find how to justify it, that what happens there. But it's still an ongoing process. So I had my second article draft is now ready. I was thinking that yes, I will do small updates, and I go to now to the main study in May. So I need to reduce a little bit more this noise, and I'm ready. And it happened something that last year, August 15th was the deadline for NARST. So my supervisors were saying, start to write it. So in July, oh, okay. So, but you know, in NARST, you need to write it, your research to some little bit different angle. Not, you know, find something else. Okay, different angle. So then I asked my daughters that, hey, can you look this test that I did? It's 9 pages, read it through. What can be the different angle that I can write? My daughter said, it's July, it's summer holiday. I'm not going to read your test, it's too long. Okay, so okay, I was able to write something, boom, submit it, oh, luckily accepted. And then I started to figure out that, okay, what it means, it's too long. What it means. And my friend Janari, who is second year PhD student, says always that, oh, Lauri, you are doing excellent work. Each time you are presenting something that, wow, it works, and then you flush it down to the toilet. And yes, this is what constantly happens with me. What it means too long. So I started to look the length of the characters I put to the each answer. And the item, how correct they are answered. And it, you know, another noise. Functional reading starts to kick in and causes problems. The longer the answer option goes, it needs more reading, more cognitive work, and you know, I'm doing small risk about 60 characters now this time, so all the answers length are 60 characters. I'm trying to find this sweet spot to do it so that my model will, I hope that will work with this 95% that my model is accepted in the M+. So yeah, this is about my work. It's constantly struggling, failing again, but science is mostly about thinking. Like Einstein said, 55 minutes spent of thinking how to solve the problem, and 5 minutes solve the problem, if you have 1 hour to solve the problem. So yeah, now I need to start thinking how I can do it so that everything works. So yeah, this is, and we have done in Estonia this one digital literacy test, and there also happened that in one student that if they put like main predictory functional reading, there were some questions that everything was supported. So be careful how big are your answer options, because everything is noise basically in your test. Try to eliminate it more. And yeah, this is about my science work study so far. In the school level, right now in Estonia, there we have also progress. We need to start to implement into our school curriculum new revised governmental curriculum, and it's in progress. And maybe something for you just from the school also, that we were thinking that 4th to 6th grade science, that maybe we should do something differently. And we started to look all the materials, and we found out that somehow we can even mix math and science together, so we can learn it together. But there is always a question when you have 2 lessons science per week and 5 lessons per math. Is it science through math or math through science? So it's constant questions with the teachers, because their beliefs are quite strong. So this is one idea that we are working on school level, that maybe we can do it something. I said that maybe let's take one this sort of a module and let's test it, and after each year when we have tested, then 2030 we are ready, and 2050, you know, one day we want to go transdisciplinary, that all the disciplines are connected. And I told this idea to our headmaster, and our headmaster said, "What? I'm dead by that, but I want to see it right now." So I said, "Yeah, well, it takes time. It takes time because the teachers need to accept it also. Because when we did, oh, I have geometry. I haven't forgotten to translate. So yeah, when we talk about math teachers, that we have this idea that we need to, you know, we have this major meta topic Earth, you know, and the math is, well, I have triangle, and then it's like, what? Okay, in the Earth there are many triangles, so you can look at on a daily basis everywhere. But it's hard. It's, you know, it's a like religious question. It's like Catholics and Protestants. So it's hard to find this. I know that you have the church here. All the religions can go, but in Estonia it's still on progress. So thank you for listening, and now our questions.
Questions? Comments?
So I have a question. So for reducing the noise, usually we drop off something, but
Yeah.
in your case, you added some details.
Yes, because I had 16 items. I took small risk that I need to have four items that are under one latent variable. 4 is too big risk because for justify your system you need to have at least at end 3. 3 is the minimum. But if 2 were already not fitting with the model, then I needed to add more. Yes, and it means that reduce the content text that is written before. Otherwise, you cannot do it with 45 minutes. Yeah, that I'm doing the opposite way, and it works sometimes. Yes. And really good question. I suggest do not never ever if start to do something that you create your own instrument with your own items. Please take something that is already in the literature. It makes your work so much easier. They have tested it, they have done it. Bicycles are there, we don't need to invent them anymore. I have done everything so stressful. But now I'm third year, you know, we have the smile already. It's better, it's getting better. Usually in Estonia it happens also that when we have this first doctoral seminar where all the older PhD students are representing their work or giving some sort of a wise thoughts for the first year PhD students that what to expect. And it's usually like, I think you go to forest to pick up chanterelles or, you know, something. And it's usually that people are posting on social media that, 2 baskets full of chanterelles. And then you ask, where are the coordinates? No answer. Nobody will giving you this, chanterelle spot where you can pick them. So your PhD is like so. 3rd or 4th year, they have the smile, and the 1st and 2nd year, it's mostly about stress, anxiety, depression, and again. And if you survive, it's a journey. Yes, John.
What do you think is the implications of your work for curriculum developers? People who are trying to make better science curriculum.
Yes, of course. My main idea was quite critical, but the main idea was at first that if you start to look the science education, since we see that like 1/3 of the learning outcomes right now are related with energy, maybe we can reduce the amount of subjects we have. Maybe we should have this unifying subject called energy, but or maybe we should go more to this into field where we have one unifying subject at all. It's called science. That we mix them because it's actually the real life. It's quite interdisciplinary, transdisciplinary work. But there are still believers who don't believe, and it's my lifetime work to make them believers. Like Joe said, we have 2 states. We need to work on them. The NGSS are free, but it's already like, yeah, it's the key factor is always teacher between curriculum and the students. It has Estonia happened before that when the curriculum is bad, then the teacher they are doing more. So they want to do more, and they give maybe extra, but yeah. So it's the key factor is I think like with the computer, it's between the chair and the computer is the key element. So let's see. Okay, more questions. Yeah.
Well, so I'll follow up on Jonathan's, right? Let's extend that, right? He asked you about curriculum development. You've changed the focus instead of the issue is the teacher sitting between keyboard and chair. What would you do? What are the implications of your work for teacher education, teacher professional learning?
Yeah, because I'm now also in chemistry institute working there. I have this course like chemistry in school, where it's the first year bachelor students are when they are coming to study to become science teachers. So I have the power to change their views. So after 10 years when they are in the market, in the labor market and working as a teachers, I cannot make the old pairs to dance. I can change the new fresh ones, the small ones. They are easily changeable, let's say. And also I can support and do the cooperations with different institutes, so I can go and promote it there. This is the main thing. So it doesn't happen so that you write different new curriculum with the new ideas. It means that teachers, like the STEM studies are showing also, that if you choose some sort of module, the teachers want the entire package, do like everything. If you say that, oh, this inquiry-based 4 lessons module, it shows great results, but they say, well, I have 70 lessons to cover. Please make me the entire package with all the workbooks, textbooks, supporting materials, and everything. Then I will use it. But not the small things. Like they don't believe that the small things can make the big thing. So it's but teachers are okay. I'm also a teacher. I don't blame them. It's the belief that usually when you go to teach in the school, you do it the same way like you were taught. So it's you need to change them in the university. So they go to the field and they start to do it differently. So yes.
I have a follow-up to that follow-up now. So you say that like just changing over your teaching in universities. In the US, we have this really big problem with this disconnect between universities and the districts we send teachers out to for mentor teachers. And we see it's called the 2 worlds pitfall.
No.
Because it's a difficult question. Like, I mean, it's like a big field goal question that you can talk about like that. It's like, we could change the way we teach teachers at university, and we've kind of done that pretty well here, but then we send them out to mentor teachers who are very traditional.
Yeah.
And then the students are like, they can't bridge that gap, and so they end up just either at best compromising, or at worst just siding with their mentor teacher and saying, all the reforms are stupid, we're just going to go back to the old ways because these teachers are in the field, they know what's up.
Yeah, but over the time things happen. People have changed their religions, and it has happened, but it doesn't take years. It takes decades. You are 3D learning, promoting it here in the state level, and it's still an ongoing process. It takes time. you can give some implications. Yes, we need to do on this level, this level, this level. But it's we have luckily we have 500 schools, so we need to do the lobby work there. Yes, 500 schools. You have plenty of more. So we need to send our minions to promote it the way it's taught, and actually I'm pretty sure that since there is no competition in Estonia, the idea that NGSS has, it is huge. It's also really much implementable in Estonia. So I do everything with next 25 years to pull all the ropes to lead people into this direction, because it's important. Yes?
So to go back to your energy concept test, so you said that your first efforts at it didn't work because you couldn't get it to factor.
Yes.
So have you considered why do you think it would factor? There's a fair amount of research here in higher ed, because the concept test was very fashionable for a while, that in fact the nature of students' knowledge is such that you wouldn't really expect a test like that to factor, because their knowledge is still very fragmented.
Yeah.
And there are no connections.
Yeah.
And it's entirely contextualized within the problem. And I just wondered if you had thought about that, rather than the problem wasn't with your test, but it was with the nature of the knowledge that you were trying to test, because energy is notoriously difficult.
Really good idea. Again, the next presentation, Melanie Cooper, is on my slide and giving me, yeah, really good.
And then Melanie said.
So it's the question, is the glass full or empty? Is from which direction you watch? Yeah, if you watch snowfall, is it from inside or outside, from the snowflakes perspective? No, I haven't considered it, and it's a really good idea, yes?
Yeah, I've got some references for you, I can send.
Oh, yes, thank you. It's really good. That's why I'm here, to learn from the masters. Yes, I need to consider, and now I know when any professor is saying anything to you, it's not to grill you, it's to support you. And it's mainly that they know, they have the bigger picture. Yeah.
Not necessarily, but
Yeah.
I think it is to support you.
Yeah. It's lovely to ask all the things that what might be there. And of course, it's impossible to take the Estonian curriculum and put it here and hope that it works and you will have this 30% PISA score goes up. I don't believe that this can happen. And even if I think that Joe studies have shown that with the project-based learning you can improve up to, in the major mega population, this 7-8% academic test. So if I multiply 7, it's 35, if I add this to our PISA score, I can see that we are never going to be top 1. So basically, statistically our population, if this 7-8% is the max you can get out, we are never going to be on the top. We don't have in our population this capacity that it can, there's limit in the population. Yes, I can see that it's sad. Maybe we want to be always top number 1, but Europe is good for enough, not the entire world, I think. Yeah. Any more?
I probably have one comment about your assessment analysis. I saw you on one page you have one is rush analysis.
Yeah.
Another one is you use the CFA.
Yeah.
Conformative factor analysis. So based on my understanding, the two is rely on different theoretical assumption. For one, you treat the energy as a unidimensional.
Yeah,
So that's why you run the rush analysis. For another one, you have a three dimension. the
yeah,
three
yeah,
bars.
yeah.
Let's assume you have three dimensions about understanding about the energy. So yes.
Yeah, all these things in Rush also didn't work. So yeah, we in our statistical course in the university there is like 15 guideline steps that you need. Start with SPSS, ANOVA. Like if it gives you already the candy, you are winner, and go. If it doesn't, follow up. Rush. Start to look the items because it's item response theory. You start to look the items. Maybe there is something in the items because David automatically saw that, oh, yes, there is something in the items, but there is so much noise because it's three-dimensional. They are somewhere flying around, randomized. It's, but think of everything that take down, make it smaller, and then maybe I can one day go to 3D again. But right now, two-dimensional, it seems working, and yeah, it's I need to basically take steps back and start to build again. Yeah.
Thank you.
Great, well, thank you.
Thank you.
So Lauri will be around for the rest of the week. If you, he does have time in the schedule per time. If others want to meet with him, just let him know and he can
Yeah,
figure out how to meet with you.
yeah, and I will knock on the doors maybe and ask my question. You have really good institution, and this is also my dream also that in Estonia, because maybe we are spending too much money to be individualist. Together 1 + 1 is actually 3, and the institutions maybe don't know that if we apply together, we can be more successful. It's supported in the education and science globally. So yeah, it costs less actually, but beliefs again the beliefs are so strong. Okay, thank you.
Thank you.